Professor Pat.
Well, hi there, Jimmy. Are you ready for class?
Aw, gee, I sure am. Our biology class has been bonkers lately, so I'm coming in on my own time for help, just like a good student should. Ain't that right, Professor Pat?
Right you are, Jimmy.
Oh, you.
Well, come back along with me, Jimmy.
But Professor Pat, what is tuberculosis? What are protists?
Well, Jimmy, all the answers you seek lie right here. Right now, we are looking at tuberculosis, magnified 15,000 times. Its name originated from tubercle, which means exactly what it causes. A lesion in the lungs which has suffered severe swelling or aggregation of the cells. If one happens to catch tuberculosis by breathing in airborne TB germs, the symptoms could be quite severe. They might start to cough, have chest pains, or even start coughing up blood. But the worst part is, they might not even know they have it until it's too late. To better understand tuberculosis, we need to dive into classification. Tuberculosis is classified all the way down to Mycobacterium, making them belong in the bacteria section of the tree of life. TB cells are also classified as bacilli, which means that they appear to be in the shape of a rod. This brings us to structure. Now, I don't blame you if you thought that tuberculosis looked an awful lot like the average prokaryote, because it does. Just like regular prokaryotic cells, TB cells possess a cell wall and membrane, ribosomes, cytoplasm, DNA, and many other organelles. However, what makes it unique from others is that it is non-motile, which means it does not move via cilia nor flagella, and that its cell wall is made up of peptidoglycan rather than cellulose or chitin. This makes for the cell wall to be over 60% lipid, giving it a thick, waxy, and mycolic acid-rich covering.
Yeah, I get all this structure and function balderdash, but tuberculosis doesn't seem all that dangerous. Can't we just kill it?
Well, Jimmy, it ain't that easy. You see, TB cells are neither gram-positive nor gram-negative, which means that they can't be identified through staining. Think of it this way. Imagine you have a petri dish filled with bacteria. If a scientist wanted to either distinguish between different species of bacteria or just make them visible in general, he or she would dye them a color. However, due to the special cell wall of tuberculosis, it doesn't retain any bacteriological stain, therefore making it near impossible to find on its own. Also due to its cell wall, tuberculosis is resistant to many antibiotics, resistant to killing by acidic and alkaline compounds, and can even survive inside of macrophages. Thankfully, there is a solution. Recent scientific research has shown that TB cells have a weakness that could be the solution to instantly curing tuberculosis forever. Within the complex wall and membrane of the TB cell, there is a wacky little enzyme called RV3671C. I couldn't even make this stuff up if I wanted to. This enzyme is so important because it acts as the cell's main defense when consumed by a macrophage. If these enzymes were to be eliminated, then the TB cells will stand completely vulnerable to the macrophage's gluttony.
Wow, Professor Pat, I really have learned a lot today.
Well, I'm glad, Jimmy.
But Professor Pat, I don't get how you're supposed to prevent tuberculosis.
Well, there are various methods. Wash your hands. Use plenty of soap. Get your vaccines. Take a walk every now and then. Have good table manners at lunchtime. Don't make eye contact with the principal. Smoke Lucky's cigarettes. Don't walk down dark alleyways. Avoid hugging your grandmother. Stare at the sun periodically. Daydream, but don't take in a deep breath when at the gas station. You want more? I can keep going. Drink please. Gives you lemon and probably lung cancer if you smoke. Hail Hydra and cover your cough.
Well, have a nice ride home, Jimmy.